Okay, hi grade 12s. I'm back. I want you to go through a couple of examples with me on page number 29. All right, we're going to look at the table. I'm going to do a few with you, and then, of course, you can have a look at the solution set. So let's do a few just to get the format of what we're looking for. How is it that we determine what the intermolecular bond type is going to be? Okay, first of all, the first thing you need to do is we need to be able to identify the polarity of the molecule. Okay, this molecule right here, bromine and bromine, well, we have the same non-metal atoms together, which means if this was bromine, right, it's not, it's hydrogen, but if it was bromine, they have the same pull because they are the same type of atom. So that is a non-polar covalent intramolecular bond, which means there's no polarity to that molecule. That's the first thing. You're like, this is a non-polar molecule. So if it's a nonpolar molecule, what are my three options? I'm looking at either an instantaneous dipole, a dipole-dipole, or a hydrogen bond. Nonpolar molecule means it is an instantaneous dipole bond. That means that between one bromine and another bromine, it has a very weak intramolecular force holding those two together. Okay, now let's do water. We've done this one. We just explained it a few times, haven't we? All right. First of all, I can put the bond polarities in for my molecule. And you do that again with an arrow, slightly negative towards my oxygen, slightly positive towards my hydrogen. I'm showing my bond polarities on here. How do I know the electrons are held closer to the oxygen? Do you remember? The oxygen is a more electronegative atom than hydrogen, so the oxygen is pulling those electrons towards it. That means that we have a polarity to the molecule. The next thing I check for, I want to know if that molecule is polar or is it very polar. Okay? If the inside bond has a hydrogen directly attached to a nitrogen, an oxygen, or a fluorine, which it does, it creates a very polar molecule. Okay? Very polar. Therefore, what's the intermolecular bond type that it has? Instantaneous dipole, dipole-dipole, or a hydrogen bond. And of course, we've done this a million times. It is an hydrogen bond. And again, an intermolecular force. We're just going to call it a bond, but remember, it's not really a bond. It's just a force that holds them together. Let's do the next one, and then I'm going to let the rest go for you. Actually, let's not do that one. Let's do, let's do this one. Let's do boron trihydride. Okay, so for boron trihydride, we have a molecule here that has bond polarity. Is which one's more polar, the boron or the hydrogen? Yep, you guessed it. It's boron. Okay, slightly negative, slightly positive, slightly positive, slightly negative, slightly positive, slightly negative. Okay, that's my messy bond polarities I've just added on. They are all equally spaced around. Do I have a molecule ready to go that looks like this? Yes, I do. Imagine imagine this is boron and these are hydrogens. Ooh, they are, okay? They have an angle between here and here of exactly 120 degrees, exactly 120 degrees, exactly how 120 degrees because it's on the same plane, okay? They are equal in magnitude because it's the same two atoms that are between all three of them for this overall molecule, equal in magnitude, opposite in direction. They cancel each other out. The molecule is non-polar. See all those four little points that I'd be looking for if I was the teacher and I was marking your answer? Okay. You have a non-polar molecule, and you definitely want to be able to explain that. Again, you could add these two vectors up and there's not going to be any extra electrons any other side. So if you have boron trihydrate and that's what it looks like, what is the strongest type of intermolecular force you can have? Nonpolar molecule, instantaneous dipole bonds. Okay, so I think now that you've got a good handle on this, give it a go, right? Add in all of your rough work to show your thinking. And then your answers, again, there are only three of them when we're dealing with just the molecular aggregates. And then the last thing would be if you have not filled in the page that has the physical properties on it. Where is that one? It's back here, sorry. I believe, yeah, it's right there. Okay, so at the bottom of page 27 and 28, you want to go over now, well, how can this be explained at the molecular level? Okay, you've got lots of good terms in there. Do some highlighting, do some pulling out of the words, add to it, make it your own note. Okay, and then once you've got a good understanding of it and you're ready for some tricky questions, then you're going to work on the questions that are on page 30. Okay, there's lots to do here. The next section is just going to be the metallic aggregates, and then we're going to sum it all up. I'm going to teach you what the shapes are called for the molecules, and we'll revisit the idea of polarity again. All right, good luck.